This is a really short demonstration of why natural logs are the same as regular logs with just one difference. They have a set base, which is the letter E. E is a number just like pi, where it goes on forever. There is a button in your calculator for E, so you don't have to worry about knowing what it's equal to or anything. So before I even get into the expressions that I have on the screen right now, I'm just going to do a very quick review of regular logs. So let's say you have the log of 10. I don't have a base written in, so it is 10. You always assume that the base is 10 if you don't have one written. And one of the properties that I've taught before is that if these numbers match, the answer is 1. So keep this in mind. Let's say I have a different log. Let's say I have this one. So this time, my numbers match again. If that is the case and you have an exponent, the answer is the exponent. So keep these properties in mind. The first one I've got here is the natural log of E. Anytime you see natural log, the base is E. This is just a special type of log where the base is automatically E. So I write in my base of E if that helps, and you can see that E and E match, just like I've got in this first one over here in the box. If those match, the answer is 1. Similarly with this second one, it has a base of E because it's a natural log. If the E's match, the answer is the exponent, so the answer is x minus 3. Now this next one is a little interesting. I'm going to show you a few different properties or a few different things that we're going to do, including one of our log properties that I haven't done in this video yet. So I have E, but it's being raised to an exponent which contains 3 times the natural log of x. If I have a 3 in front of the log, remember that would be our power property. What I'm going to do is do the reverse of that. I'm going to move that 3 back into the exponent where it would have come from if I used the power property. So now we're going to have to figure out how to simplify this. I don't know what this is equal to, so I'm going to say that it's equal to question mark. And my goal is to figure out what is question mark. So believe it or not, this is considered exponential form, even though it contains a log. This is exponential form because I have a base and it's being raised to an exponent. That exponent just happens to contain a log, but that's okay. This is exponential form. What I'm going to do is convert this to log form. So when I convert to log form, the base, which is E, moves to the other side and it becomes the base of the log. And then what you're left with is the exponent. And in this case, the exponent is natural log of x cubed. That's a 3. Now, if you have a log with a base of E, we do not write log base E. A log with a base of E is what we call the natural log. So I'm not going to write it like this. I'm just going to write ln for natural log. So the natural log of question mark is what I have on this side. Now again, the natural log always has a base of E, so you can write it in if that helps. And now we have the natural log of x cubed is equal to the natural log of question mark. Remember, I'm trying to figure out what is the question mark. Well, in order for the left-hand side to equal the right-hand side, that question mark has to be x cubed. So after all that work, the answer is just x cubed.